So yeah, glad everyone's here today. So in terms of the topics, what I kind of posted about before was that yeah, generally we're going to be talking more about the sort of problem spaces that we're interested in right now, rather than any kind of new concrete proposals. Yeah, I mentioned Vivian had some written out, but yeah, you want to save your voice for the presentation after this, which makes total sense. Jeff, you said you might have a little bit to talk about, not necessarily
I,
tons.
I, I do,
Um,
and so I was like, oh, you have a little time, I'll squeeze it in. But now Vivian dropped out, so now I
right.
think maybe I'm the main event.
Well, to help
So
you, I have also written out some stuff. Um,
okay,
so so
I
I can
did I
also go through
did
that.
in the last half an hour. I tidied up my notes so I could present them.
Okay,
So
nice. Yeah,
so I am
my
prepared.
notes
I
are
am prepared
very
to
bare
talk.
bone, but
Well,
essentially
yes.
it's just about kind of some of the stuff we've been talking about recently about policies that kind of explore more and just trying to think about how prediction error could be a more kind of unifying way of thinking about a lot of things that we talk about, including unsupervised
All right.
learning and all this stuff.
Well,
But
my topic's all related to how multiple columns work together, and there's various problems that are related to that. So
yeah, it might be
if you
better
want,
to start with yours if and
that's fine
then
with me. I don't
okay,
know, it's
cool.
fine. Um, yeah, so a general caveat here, I'm talking about neuroscience again, and so we may have solutions to some of these problems in Monty. I'm trying to understand how the brain does things, and so that doesn't mean we have to do it this way. Um, and then the other caveat is it's just some typed up notes as opposed to some nice presentation. And I don't have solutions, but I have some ideas about solution spaces. So let me just share my screen, and then I will then go here. All right, so here's a Word document. And This is even better because now I can see everyone's face and this text at the same time. So as I started with, I'm working on a bunch of problems. And you can see, I hope you can see it says problems related to multiple columns modeling the same object. And I want to point out that none of these problems exist with a single column. So when we had a single column or a single learning module, we don't have to deal with these issues. It's only when we start dealing with multiple columns working together that we start to have problems. The number one here is one and I think these four things I'm listing here, I think are all related, and I think they may all share a solution. So that's why I've grouped them together. So the first one we've talked about a lot, well, somewhat. The idea of shared learning that we need if we have a region with a lot of columns, all those columns have to have similar models. Not exactly, again, not exactly the same. They're not like clones of each other, but they have to learn models of the same objects because they have different features and different scales and things like that. But they're all the columns in a region for voting to work. Our whole idea of how the brain works is that these columns all have the same models. Yet we don't really have a way of training all those columns. It's unrealistic to expect every column in a region to experience every feature on an object, and yet we kind of require that. So this is the problem. How and I would phrase it as how do non-sensing columns get the input needed to learn? So I may have a column that's in part of my retina, that's representing part of my retina, and that part of the retina hasn't seen the coffee cup, but it needs to be able to model it when if it does see the coffee cup, it needs to say, yeah, I'm on the coffee cup. And so
And it,
that's a
maybe to
problem.
do the annoying thing that I guess do parents do and bring up examples from kids or whatever. But I feel like, yeah, a recent example that I've been thinking a lot about with this is, babies, they put stuff in their mouth so much. And the typical argument for that is, oh, at least at that stage, it's the nerves are even more sensitive than their fingers. And so it helps them kind of build a, model of what this object feels like. But it's like that wouldn't be particularly useful if that model is only going to stay in your,
In your mouth.
outside of things like food and stuff. It's kind of unnecessary to
Yeah,
have all those bottles in your mouth. But
yeah,
if they're somehow being learned elsewhere, then it makes a lot more sense.
right. This is right, and this is a really interesting problem because I say it's in one region, but you can make the argument, like you just said, the mouth. It's really weird. I mean, it's like I can infer something sometimes with maybe the back of my hands, which have never felt anything. How does it do that? And the old days we used to think, well, the input low down would get sent up some higher region and we'd take care of it, but that's just passing the buck here. So there's a general problem about like how do columns learn when they're not experiencing stuff. somebody's experiencing it. Some columns are getting input, but we need other columns to know something the same. Another problem we've had from the very, very beginning um, is this issue of relative pose of columns during voting. So, right, right, if you're just voting on the voting ID, it's sort of like a bag of features, and it's still very helpful. And as soon as you start moving at all, columns will start quickly. You'll still get a lot of advantage in voting. It doesn't go away, but you wouldn't if you just took a flash image or something and nobody gets a chance to move, and you have a bunch of columns sensing an object. Then it's really a bag of features, and we don't think that's sufficient. So how do somehow columns posed need to be affected by other columns? And again, this is something that doesn't show up with a single column because single columns have to move. Um, so the third one is one we haven't talked about, but I've been aware of it for a long time. It's related to the other ones. So you try to imagine now, I'll try to paint a picture. You've got you're looking at a line drawing of an object and it's projected onto the back of your eyeball. So there it is on the retina. And now you move your eyes and it's now in a different position on your retina. Well, there's a good chance that almost all the columns now that are getting input were not getting input a moment ago. Um, there may be little or no continuity between which columns are getting input. So now a whole bunch of new columns are getting input. And but if I inferred the object before I move my eyes, it's not like I have to infer it again. It's like once I recognize it, I've recognized it. And so I call this the columns moving on and off object. It's like I could have a column. So imagine it this way: I have a column that's representing part of the retina, and right now it's not getting any input, but the rest of the system has recognized an object. Now my eye moves, and this column now moves onto the object and sensing a feature on the object. Well, does it enter that position knowing nothing, or does it enter that position saying, "Oh no, I know where I am. I'm at this location. I should be predicting this." I think it's that. I think that's the truth. Now, if I was a column looking at part of the object, like the edge of the object, and the whole system has inferred the object, so we're all locked into it. And then I move, and I'm a column. I now move off the object and I move back on again. Well, that one works because I could be on the object. I move off. I know my position now relative to the object because I knew where I was. Now I'm off the object. I know where I am. And if I can do path integration, I come back and say, so when a column is not observing the object, it has to maintain. It's like, oh, I know what object I'm observing. I know where I am. I'm not actually observing the object right now. I'm in some space relative to the object. But when I move back on, I'll know if I'm on the object again and where. So, so this is really, it's a question of like, okay, that one works, but what if the column never observed it to begin with? The column was not on the object, and now for the first time, it comes onto the object. Um, you could think of it also like, if I was touching an object with three fingers, now touch it with my thumb. Well, my thumb wasn't touching it before, but my thumb expects it knows what it's supposed to get. So the column representing the thumb must know where it is relative to the object, even though the thumb's not getting anything. So I don't know if that is obvious what I meant by that. I call it columns moving on and off objects. Did anyone not understand that or have questions about it? Okay. Um, the fourth one here is one that I think we came up with in Milan. We were talking about it, but I don't remember. I don't know if we remember talking about it in the whole group or not. But we've talked about it someplace. I've talked about it. And this is the idea that we're trying to understand how it is you can have an existing model of something, and then at the moment you see a temporary arrangement of features or some temporary change to it, and you want to incorporate that. So I use like the example of the intersection, where I have a permanent model of this intersection I see every day. And today I see the bicycle at some corner. Well, I have to somehow know that the model of the intersection includes the bicycle right now, and then a moment later it won't be there. So we don't think that's happening in lower cortical regions. We think that kind of memory is in the hippocampus, where like, oh, right now that at this time of day there was a bicycle going this direction. And so how is that combined? How do I see the intersection with which is presumably stored someplace, or doesn't have to be an intersection, it could be any object, but I have the sort of more permanent model of an object, and then there's some temporary features that are moving in and around it that are just today's variation, and yet somehow they're merged together. I don't see it as like, oh, there's the permanent intersection, and now over here I have the independent little moving parts. It sort of seems to seems like there's this one model of the intersection which incorporates prior knowledge I learned a long, long time ago and things I just observed a minute ago or a second ago. And they get integrated somehow into a single percept. It's as if we had a single model that had all that stuff. And so if I assume that the hippocampal complex, for example, is where these episodic memories of like the bicycle was heading towards the dog or something like that, um, then then somehow there has to be sort of a merging of these models between the hippocampal complex and wherever the base model is stored, is presumably in the cortex. Um, so that was an interesting problem. Like, how do we merge these things together? And I'll get to we had an idea about how to do that, which I'll talk about in a second. Right next, unless there's any questions. So these are the four problems that a set of problems. And I just this morning I said I better make a list of them because I never really made a list of them. So make a list of them. So maybe I forgot something. I don't know. Um, but these are all sort of problems that are related to how do models get combined across multiple columns. Um,
Um,
no questions
how do
about
I
those?
no? Oh well, I have a question, I guess. Do you think it's important to make a distinction when we're talking about like shared when you were talking about shared training, you were talking about like eyes and hands possibly, but like so it feels like there's kind of two modalities or kind of two sensors that are kind of moving independently from each other while columns are moving on and off object. We were talking just about like um, whether it's in kind of whether an object lands in different parts of the retina, but I feel like I can see how columns that are nearby, or I guess you can group them by um, what muscles move them. Like if it's in one part of the retina and like an object ends up in another part, I feel like yeah, it makes sense for the other column to also know what's happening because all those columns in the retina or all the columns in the eye are controlled by like the same six ocular muscles,
Mm,
while it may not be while but in the case for like the eye and the hand, oh my god, in the case for the eye and the hand, um, we might not think that they would learn the same models, not because they're just different modalities, but because their movements are independent. So like all the columns
right,
that move together, like they will get the same movement vector, even whether they're sensing
right,
anything or not, but not for the hand. So like, is it important to make that
right.
grouping, or are we trying to make that
Well, no,
shared
I think that's a
training?
good. I think it's a good distinction. I mean, we can. I started off with thinking about just the retina. And so they're all
Okay,
moving together. And the problem exists there. There's clearly the problem exists in that space. Um, and so we have to solve it for that one. So we can remove the issue about, hey, what happens when they're independently moving? So we have to solve it for there. But then let's take, instead of going from the eyes to the hand, we can say let's different fingers. Well, different fingers can move, my fingers are in the cortex or in the central cortex. They're represented right next to each other in the cortical sheet. Yet they can move
right,
somewhat independently, right? And I gave the example of the thumb, in the moving on and off objects, but it's the same idea. So the thumb and the forefinger can move independently pretty well, to certain degrees. And I think this property exists there too. So you might say, well, okay, and those things are near each other on the cortical sheet. So you could say, well, maybe it's a property of the cortical sheet, not the movement, right? Because columns in an area might all be
yeah,
working together somehow. But I do think the two fingers shows that you don't have to have the exact same movement for this shared training to be effective. And I would say when it
right,
comes to eyes and fingers, I don't know. I threw that out because sometimes I think, yeah, it works there too, but I don't think that's important.
yeah,
I think the problem can be expressed just with the retina and with fingers, parts of your hand. And I think if we just focus on those and we understand the mechanism, then we could say, oh, maybe it applies to cross modalities too. Um,
okay,
So we could
Do you
spend
know
a lot
if
of time thinking about
yeah,
cross modalities, but I don't think it's worth it.
Well, I
right?
think
Do you know
it
if
seems like
left and eye, right eye? Oh, sorry. Go ahead,
okay.
Vivian. Sorry.
I was just gonna say it seems like the solution should be able to deal with different modalities. Like I can see the mark and recognize it visually, and then I can reach out for it with my hand, and I know what features to expect at what locations,
Yeah,
or I
Um,
Right.
can
I think that's what
learn
you
about the
said,
mark
But
Jeff.
just
that,
I
looking
think you
at
were
it.
just saying the way to solve it would be to focus on the simpler setting, right?
right.
yeah.
I think that right. I'm not against the eye ear thing. I think it does happen, but it may be a little bit more complicated. I don't know. It's just focus on the simplest ones that we know has to happen. And I think once we understand the mechanism, we can say, oh yeah, well, it would apply. For example, if it requires some sort of hierarchical processing, I don't know, maybe the eyes and fingers would work differently. I don't know. Yeah,
Yeah,
yeah, right. So
if we only focus on the simple case, we're just worried that we would find a solution that relies on some assumptions that wouldn't apply in the
that's
more
true.
complex case.
But this is why I did introduce the two fingers because I wanted to move away from the idea that Jose
Yeah.
suggested that maybe they're moving together. So we can say, well, no, they're not. We're definitely not going to focus on. We're not going to focus on a solution that says these things are moving together. Um,
Okay.
and right,
Yeah, and I guess if we just make sure to
and I'm
have in
with
the back of our mind that
right,
they're
right.
getting totally different types of inputs
Right,
potentially.
right.
Okay.
So it's easier to think about certain problems like the retina or the fingers, and then I'm with you, Vivian. Don't forget that we want to every once in a while say, hey, does this work across modalities? What would be the issues there? Um, but that's harder for me to think about is than for some reason for me just to think about fingers and retina. Um, I don't know.
Okay. Yeah, sounds good.
Yeah.
Hopefully this
So
isn't sidetracking, but I was just thinking about I was just thinking about trying to feel an object and this idea of attention. I'm just imagining like if there were two objects in the world and I have one hand on this object and another hand on this object, I can't try to learn both at the same time. There's definitely something that's attentionally gating whether or not I try to learn from my right hand
wait, are they on the
or
same
from my
object?
left
I'm
hand.
sorry,
There are
Scott. Are they on the
two
same
different
object or different
objects,
object? Right,
two
right,
objects, two
right,
hands.
right. I agree
Like
with that.
I can't be, there's
But it's
definitely an attentional gating here.
When
but
That's
you can attend to your right hand, learn an object, and then you can infer it with your left hand afterwards. Um,
yeah,
so it seems like yeah, the attention thing is kind of the idea that we mentioned before that you can only attend to one location at a time. But then the learning, it still seems like it can happen in columns that are not currently sensing at that location.
right.
right, right. It has to almost. It's just kind of anyway. It feels like it has to. Yeah. Any more questions
Right.
about the four problems I listed, or suggest thoughts about them?
Well,
So
I'm
the
thinking about the.
Go ahead.
Go ahead. I'm just going to say I'm thinking about the permanent and the temporary features, and I'm wondering if there is a clear line between them, or like what is the definition of a permanent and a temporary feature? Because sometimes, like even in the intersection problem, a temporary feature, if it stays there long enough, it becomes part of the model, and whether
Right,
that
right, right,
process is gradual or
right,
yeah. So
right.
maybe clear
But
definitions
clearly,
of
but the reason I
yeah,
brought it up, Rami, is because I felt like some of these are definitely in the hippocampus, right? I mean, it's the general neuroscience dogma
yeah,
that certainly episodic memories where you assign a time to it is hippocampus, and we think about the very very quick noticing of very short-term memory things is hippocampus. I don't know, it's questionable whether other parts of the brain cortex do that too. So I don't know. I mean, it's possible that maybe V1 has super fast memory as well. I don't know. I haven't seen any evidence of that.
hmm,
So then my basic assumption was, okay, well, at least we don't have to put a hard line between what's permanent and what's temporary, but they're in two different places. That was the thing that struck me, is like, wow, is it really true that I have a model in visual cortex and I have some new things I've observed in the hippocampal complex, and those are in two places, different parts of the neural tissue, and somehow
yeah.
they get merged into this sort of single percept, you know
It's
Um,
difficult to think about them in two different places because then that raises more questions like when does it move from here to there, or like
well,
are we
right,
learning both at the same time? And
Yeah,
right,
I mean,
right,
it's I
exactly.
feel like it's most intuitive if, I mean, who knows if this is correct, but it's most intuitive if you think about them learning in parallel. And so it's not like anyone has to decide, oh, this is a hippocampal thing. Cortex
mm,
don't get involved or anything like that. Cortex is always going to try and learn and update its models, but it's just going to do it really, really slowly. And so in practice, the only place you would see a representation emerge after a very brief exposure would be hippocampus,
Right.
or like prefrontal cortex, to your point, Jeff, or like about whether this happens in cortex as well. Like I think there's some evidence that prefrontal cortex can also form really rapid representations. Um,
Yeah, I mean, you've
so
said that
are
a
you
few times.
saying that?
I went and searched for that, by the way. I couldn't find, I was looking for
oh,
like
okay. Let me see if
as
I can.
well.
Yeah.
Well, I associate. Excuse me. I'm sorry to interrupt whoever else is speaking. There's there's the idea that one place, the place you see neurogenesis, like new neurons forming all the time, is only in like the hippocampus, like the dentate gyre or something like that. And I associate that with this sort of episodic memory, this sort of temporary memories. Like you're introducing new neural tissue all the time, so it's going to learn something new. But I didn't see any evidence of neurogenesis anywhere else in the cortex.
Yeah, not
But
neurogenesis, but more.
but that,
So, for example, like working
the
memory,
sign.
I think is
Well,
is implicated a lot in prefrontal cortex. And
yeah,
there's some camps that argue working memory is just maintaining certain neurons active,
right,
and but
right.
there's some camps, and there's evidence for this, that it also involves synapses forming.
Oh,
Because they can
okay,
basically, I can't remember the exact experimental details, but they can basically silence those neurons, but then they can still recover the memory from prefrontal cortex. So it implies that somehow it was kind of frozen in some weights that even
right,
when the
right,
neurons went
right,
offline were
right.
still um,
Right. So one way to think about this, you can imagine you've got a bunch of these, and remember, I think that what's going on in the hippocampal complex is very analogous to what's going on in the cortex. So you can almost, for starters, say it's like cortical columns plus time episodic memory. It's a rough approximation, and and so now you can have different learning rates at different places, and but so we have to deal with that issue, like how do these get combined eventually with because obviously the cortex, Niels is saying you could be learning simultaneously in the cortex, which apparently thinks it does happen. So to me,
Mm,
the problem I was focused on here was a different problem. It's how do these get integrated? How is it that if I have essentially models of the same thing, but they're in different places, and somehow they get combined into a single percept. It's very much like voting. It's similar to that in some sense. You have different models that do different things, and yet you have one percept of it, and it just becomes really sort of in your face when you start thinking about hippocampus and cortex. Like, oh, I have some knowledge in the hippocampus, which is being combined with with that's like a temporary model of like where it's a bicycle, but it's being combined with a model, a more permanent model in the cortex. How does that happen? So that was where it came from.
right.
yeah.
Yeah, what were you saying, Remy?
I don't remember, but yeah, I
Okay,
don't remember.
yeah, I think it was something about the parallel learning, but yeah,
Yeah. So it means that we're also still learning temporary features in like V1, but those are just not. I don't know. They're
Well, they're not
just not
right.
being
well,
We're learning
consolidated. Like,
we're learning features, but whether they're temporary or not is a property of the world. And so if V1 runs very slowly and those features don't reoccur, well, then that's not going to be remembered.
yeah, and I
Um,
feel like maybe one way is to think about it is like maybe all learning is temporary, but it's on different time constants. So like
right.
it may
right,
take a very long time
right.
to kind of overwrite a representation in V1. Um,
But even something like V1, remember we've got a lot of evidence that new synapses can grow almost in real time. But the evidence has always been it's like on the order of a minute or so. And so it doesn't quite satisfy the requirement of, oh, I just see this thing and now I look over, I remember it, and I look over there and I see another thing, I remember it. And so that's what forces you into like okay, V1 might be learning by forming new synapses, and it may take a minute, and those synapses will be very weak, and then they disappear again if you don't reinforce them over and over again. So you might actually be forming the same memory in V1 as you're forming in hippocampal complex, but it's going to take a minute to get there. It's like, so it's not
Yeah.
very useful until it's a minute. And yet we know
Okay.
we can do things much quicker than that. So
So the line here is really just a different kind of learning that's happening in HCC, and it's forming these memories quickly and
right. The theory
yeah.
I propose, I think is pretty solid, is that there's these many silent synapses in the HCC.
Yeah.
And so these are they are sort of little miniature synapses that don't have any effect, but they're physically there. And so all you have to do is sort of enable them, which is a chemical process. And so you can say turn them on, and you don't have to grow anything. So that explains how you can learn something within one glance and say, "Oh, cow, there's a dog there." And now you turn away and you still remember the dog is there because it's 5 seconds later and you remember it. So
Yeah.
and so the nice thing about that theory, I didn't know about silent synapses, and I deduced it must be something like that because synapses didn't grow fast enough, and I deduced they must be in the hippocampus, and sure enough, that this is many years ago. And then I said, oh look, there is a thing called silent. I didn't know the term for it, but there is a thing called silent synapses, and they exist they're very prevalent in the hippocampal complex. So I said, okay, that's a pretty nice confirmation or evidence of that theory being correct because I didn't know about them in advance.
Yeah.
Okay. I don't want to rush things here, but anything else you want to ask about this? Because next we're going to talk about some potential solution areas.
No, sounds good.
All right, great. So I've already mentioned this first idea, and this is a weird idea, but I was kind of forced into it thinking about the hippocampal thing. I'm like saying, well, how can columns that are remote from each other, in some sense, be modeling the same? How do I guarantee they're modeling the same object? And so this idea was that, well, we know about our theory says that columns communicate by voting, and they're voting on some ID, like an object ID. And that object ID spreads over large areas of the cortex or large areas of the brain. And I said, well, what if that ID actually had a one-to-one correspondence with anchoring of grid cells? So the anchoring of the grid cells, as we have hypothesized, is unique to an object, and the idea is unique to an object. And so what if the ID could enforce and always had, if I know the ID, it's always going to result in the same anchoring. It doesn't even have to be learned. It would be just a mechanistically enforced thing. And so that way, any two columns, if I'm a column and I'm not getting input, but I get an object ID flowing past me because some other people voted, I could just randomly pick an activation in my column. I can associate it with the voting, the actions that are coming by, and I would associate an anchoring of my grid cells that will always appear every time I see that ID. So I don't have a mechanism for that. I don't really understand how grid cells anchor. I don't know if anyone really does. Maybe there's some new literature on that, but so it's a bit mystery. But that was like a weird idea, but it seemed like it would work. It would solve a lot of problems. It was basically saying every column who's exposed to this ID, who's not voting, who's not getting any input, would essentially lock on to a unique reference frame. So they, even if there's no information in it, it's still everybody's going. You're not just locking IDs, you're locking reference frames. So everybody is modeling the same object now.
Wait, when you say they're
and
not voting, do you mean they're not sending out votes? But
right,
they'll
right,
still
like
be receiving them to know the anchoring, right?
right.
Okay.
I'm a column. I have no sensory input, let's say. And so I can't really contribute to the voting. I can't really say, "Hey, I think it's this," because I have nothing to contribute. But I do see the actions going by, and so the voting ideas, and so I could essentially invoke an ID. It's a random SDR and associate with all the others, and right. So I'm not voting, but it could force me based on everyone else's, it would lock in me into a unique reference frame. Even if I've learned nothing in it yet, I would always have that same reference frame whenever everyone else votes on the same object.
Yeah.
So
So
everybody has their, yeah.
yeah, I was just gonna say maybe to anyone kind of listening or whatever, just to kind of clarify that that anchoring, in some sense, it's very limited the information it's giving. It's literally just like a random initialization, and just making sure that we always get that same kind of reference frame recovered. It's not like it magically shares information about the shape of the object or anything like that.
Right,
Um,
right, right. It's right. In fact, it doesn't really matter in our current theories. When you anchor a reference frame, it doesn't really matter how you anchor it, as long as you anchor it the same way every time. So if
for
there's
that
nothing magic
object
about
and
it,
different,
for
yeah,
yeah,
from another.
right. So any random anchoring is good enough. It just as long as you're just consistent about it. So that way, because these spaces don't, the way we think of grid cells, they don't really exist in. They're just some sort of abstract, space out there, and as long as you're in that space, you're good. Um, yeah, right. There's a problem with this. I said it in this sentence. It says this only partially solves the problems. It makes sure all the columns are modeling the same object. That's good, but it doesn't inform columns about their pose. So imagine we're on the retina, and I'm a column looking at some part of the retina, and I don't have any input. And and I'm gonna. This is problem number 3 above. So I don't have any input, but I do know. Okay. I can see. I've anchored my reference frame accordingly. If I could put a word on it, which I can't, but if I could, I'd say, "Oh, we're looking at the mug." I'm not getting input, but together we're all looking at the mug here. So I'm anchored to the mug. And now I move on to the now I move and now I move and I'm getting sensory input. So I'm now observing part of the mug. Um, well, good. I've already biased to say, okay, I know I'm looking at the mug, but I don't know where I am on the mug. I just know that I'm modeling the mug. And at this point, without any additional information, I would have to say, okay, I'm modeling the mug. I have no idea where I am on the mug. I have to infer that somehow.
And
So
you'd
now we're,
actually you wouldn't be on like that sensor patch wouldn't be on the mug, otherwise it would be getting input.
well, at that point, it is getting input. I'm saying, imagine I wasn't getting input, and now I move on to I am getting input. I should be able to predict what I'm going to sense. It's like my
Oh, you
thumb
mean
was not
once
on
you actually go on the object?
right, right. So I
Okay,
know what
yeah.
object I'm on, but I don't know where I am on the object, and therefore, when I move, I don't know where I'm going to be on the object, and so I won't be able to make a prediction about what I'm supposed to sense. I
Yeah.
won't be able to say, oh, I should be sensing this part of the. I just like, well, I don't know. I'm getting some input now, and I'm on the mug. Where the hell am I? I don't know. Yeah,
Yeah.
it'd be like
Could
again,
we
like I'm holding the mug with my hand, and now I'm moving my thumb to touch the mug. It would be like the thumb would say, "Yeah, I'm touching a mug, but I don't know what to expect to feel because I don't know where I am." But the thumb does know what to feel. It does have an expectation. So this is the whole.
could we get the same effect from the layer 6 cortical connections? If the one that's on the object is actually sensing the object, it knows where it is, and would be able to re-anchor the neighboring columns and maybe even give it some information about where should it be
Well, it
relative
could
to
be,
the
but
one that's
that's
sensing.
right. Right, could be, but you have to do it in some sort of structured way because I don't know it's the neighboring columns. It could be any columns, and who am I supposed to tell? And how do I know where they are? It's like I don't know how to make that work, Rami. So it's not like I spent a lot of time trying to think, well, how could neighboring columns inform one another? And I kind of reached the conclusion that neighboring columns aren't good enough. It could be a faraway column. Yeah, I don't know. It could be anything. It's like, um,
Right. Yeah.
anyway, I
I
don't think it
guess
works.
one solution we talked about before for the moving on and off the object, it doesn't really work with like if the receptive fields aren't co-aligned, but it would be the top-down connections where you have a higher column that models the scene, and then it tells the lower column where and when it should be on different child objects.
Right, but so I haven't been talking about composition structure here. I've been trying to solve these problems without that. So I
Yeah,
agree.
yeah, it was
If you
just
have, yeah,
yeah, if
right.
there's
If I
like a
have comp,
temporary model of the scene in the hippocampus and that can somehow then inform columns once they move onto an object. Oh, you should be there on the object. Um,
Yeah.
maybe it could be generalized, but yeah.
Mm. Anyway, obviously, this is a really tricky thing to think about all the different variations. Um, my next paragraph, I've kind of pointed myself into believing there's another general purpose solution to all these problems. And and I'll just maybe I can just go into it right now. This is
May-
another idea.
oh, yeah.
You know,
Oh, just
okay,
on this one. Or yeah, I
go
can also
ahead.
hold it, and but it just yeah
No,
relates to
doesn't
this one
matter.
of moving back.
Go
Um,
ahead.
I guess I was just thinking as well, like thinking about what would be predicted. I don't know if your thumb moves on to something. Like you could argue maybe the mug column or whatever, it's just expecting to be on a mug, so maybe it doesn't have any like super precise predictions. And as long as it gets something that's consistent with touching a mug, it's kind of happy. So in that case, it doesn't know where it is until it actually makes contact.
But I
But
don't believe that
okay, yeah.
because I
But
can
then if the
imagine I
prediction
can.
is more accurate, then maybe it's happening at a lower level. So like a
But
column that's actually modeling like a rim. And then it's
but
very yeah, I don't know.
but think about it, Niels. I mean, you can even imagine what your thumb is going to feel before it touches the mug, right? It's just like you
Yeah.
know where your thumb is relative to the mug. So that's the thing. You know where it is. You have even though the thumb column somehow the your body knows where the thumb is relative to the mug, and therefore it can make predictions about anywhere you touch.
Yeah.
Um, it's just there. In fact, I could do it with two hands. I could be holding the mug in one hand, and I can bring my other, not looking at it, and say, okay, I'm gonna if I'm gonna touch here, my finger in my right hand is gonna feel this, and it's gonna feel this. So there's clearly information that's being transmitted, or the part of the body that's going to touch or sense the thing knows where it is relative to it, even though it hasn't received any input yet. So there's got to be an outer loop problem solution to this thing here,
Right.
which is the next idea here. I spent a lot of
And
time
I,
thinking about. Go ahead.
oh, I guess just spelling out one kind of implicit point that, yeah, maybe it's clear to everyone, but maybe it's also a good segue to your next idea, is that if we're using the object ID to anchor the grid cells of columns that aren't currently on the object, that basically means that all of the columns are voting or modeling or thinking about whatever is in the attended area, not whatever they're actually sensing. Because, I mean, likely the columns are actually, or the sensor patches are actually getting input, but that input corresponds to a different object. So it wouldn't be like, oh my, that column in the periphery is now saying, here's that screen. The other column is saying, here's a lamp. The other column is saying, here's my desk. It's more like wherever I'm currently attending to, all of the columns, even if their sensor patches are on different objects, would be saying, uh, we're currently
Right,
attending to laptop.
right. That's a general way of phrasing that, and I had that in here. It's further down in this document, but it didn't make the cut for today. Is that there's an idea, the assumption that a region can only infer a single object at once. Um, it can never infer multiple objects. It can infer a parent object that has multiple children, but you wouldn't find two parts of a region voting independently from each other. I'm not 100% certain about that, but I would say I'm like 85% certain about that. And and so that's related to what you just said, Vivian. It's like the attended region tells us what part of this input space should we be paying attention to, which is the part we're trying to infer, and everybody's locking onto that, and everyone else is ignoring anything else they might be getting. There might be some other stuff. There may not be some other stuff. Maybe I'm looking at an isolated picture of a mug on a white background. There's no other information, or maybe the mug's in the jungle, and I got to extract out all the other crap that's around it. Um, but the idea at least there's just an idea that maybe a region always is inferring one object at a time, and
It
and there's always
it
an
feels
intention area.
it feels like it could be a gradient where like when you're really focusing on something, that's where it's in that state where that it takes over, and so that's necessary for the shared learning to happen. And that's also kind of what you might experience when you're really focused on a task and you're kind of oblivious to everything else going on around you. But it feels limiting if it's always in that state. And so I feel like if you kind of relax your attention a bit, you could imagine then columns are more free to perform inference in parallel. And then so, if you're looking at a scene, then you're more likely to kind of just notice things going on around you and recognize
I mean,
what's
that seems like it could just be solved by shifting your attention quickly between different locations. Like
But
you're just
I
not
guess
as
there's some
focused on one
evidence,
thing.
like people with feature integration theory and stuff, they've studied this a lot, like whether attention is like a serial thing or can happen in parallel. And basically, it's a bit of both. Like clearly, we can do quite a lot in parallel.
Well, interesting. I'd like to see the evidence for that and understand what that means. Um, because it may be still true, and maybe the stuff I'm saying is true as well. So it all depends what you mean by I don't know. I understand what are they
Yeah, it's like
testing there.
the classic
Um,
experiments with Treisman and others, where uh, recognizing a T versus an L and stuff like that in the periphery. Um, but yeah.
well, again, in the periphery. Um, oh, you're not talking about the ones you
It's
define.
not just in
Which
the
one is
periphery, but basically,
which one
it's how
which one
quickly
is
you can,
different?
yeah, recognize
Which
it in
one
the
is
same.
different? Is it like what you like? You're trying to differentiate L's and T's,
Yeah, that's
and they
one
see
way
what.
they measure it.
That,
Yeah.
okay, that's a that's a slightly different problem. That could be a bottoms up problem. That'd be a bottoms up solution. Like you may not, you just like which one is different as opposed to which is the T and which is the L. Um, well, we could review those experiments. I didn't bring it up today because I didn't want to get sidetracked on it, but I think I'm currently working on the assumption that there's really it's as odd as it sounds, which it doesn't sound odd to me anymore. But a region only infers one thing at a time. There's always an attention region. It's always inferring one thing. It can move that attention region around um, mentally, or it can move it around physically by moving the sensors. But there's always an attention region, and that's it. And there's one object at a moment. So, but we don't have to debate that now. I don't think it's essential to the arguments I'm having here. Well, it might become in a second. So who knows?
And all the columns in the same region are anchored to the same object, even if they're not looking at if they're not landing on that object.
Right, right. That's this idea. Okay,
Yeah.
I'm calling it an idea. I'm not. You might call it a hypothesis. I don't know, but it's an idea. It does seem to be necessary. It was sort of like that. I was forced into this thinking about the hippocampal complex because I said to myself, how would the hippocampus and the cortex going to be modeling the same thing? Having, where the hippocampus has some new features in that thing, but the base model is in the cortex. And I'm merging these together. Well, the first and foremost, they'd have to know that they're modeling the same thing, and now they're like just two columns in a region, and I don't know. Anyway, that's how I got there.
I mean, it generally
Oh,
seems like it would simplify a lot of things. Like, for example, with voting, we were previously talking about, okay, how do columns know which other columns to vote with if they are on different objects? Like, having different like groups of columns that vote on different object IDs, and that always seemed kind of problematic in like if there are just associative connections directly between object IDs, it seems impossible to take into account like spatial arrangement or anything like that. In this case, that simplifies that completely because it's just saying, well, if the object ID in the attended area is this, associatively activate everything else, no matter where they currently are spatially.
right. So it is a nice idea, but as I point out, it is not sufficient because we need to know the location. Jose, did you raising your hand on
Yeah.
purpose?
Yes, yeah, because I was trying to, but now it's like I'm starting to forget. So before I forget, one, I guess, where it says other places, I know we haven't got there yet. Other places look for answers. If the object ID really, if we buy the idea, the object ID consists unique inquiry of grid cells, one way to solve the post problem might be to use a L6B, the thalamus connection. Remember, like we had that,
Yeah, right.
yeah, L6B to
Well, or
either
L6,
first order
L6B
higher.
or L6 or L6B or L6A, because L6B we're proposing is the orientation, right?
L6B. I think
Uh,
in the Herdecrete paper it was L6B to thalamus, but
yeah, okay,
um,
it's orientation.
yeah, yeah.
L6
So
L6A is the also projects the thalamus, and we think it's the location, and we
right,
don't have
right.
an explanation. We don't have an explanation why it's projecting to the thalamus. Okay, so anyway,
Oh, okay,
keep
okay,
going.
okay, but so
Well,
L16
keep.
is something that
I
we
like your
haven't.
idea. Your idea somehow
Yeah.
is you bring in the
Well,
thalamus into this. So great.
yeah, I mean, but if L6P projects back to the thalamus, so if one column is like recognizing, has an object ID, but has a grid cell anchoring, and the L6P is connecting back to the thalamus, that thalamus can connect to other columns to kind of tell that column, oh, we're looking at this. Your pose must be this relative to the object.
Well, okay. So look, this is we first started. We said, oh, I have a bunch of columns who know where they are, and I have a column that doesn't know where it is. So how can the columns that know where it is inform the column that doesn't? And
Mhm.
I don't think it worked because this is a many to one or n dimensional n squared problem. Like, well, who do I look? Who's going to tell me? And,
Okay, okay, okay.
right? There's a lot of columns in different places in the object. Which one am I listening to, and how are they going to inform me in some sort of structured way? And what is the Then we came up with the idea. Well, maybe your nearby columns will inform you. Something like that. It's like, well, it doesn't always work. So we started off that path like somehow there'd be this local knowledge within a region that these columns would communicate with each other. I mean, that's how I described it in the Thousand Mains book. I said, oh, they're like, there's these, my little agents walking around town, and they just need to tell each other, communicate where they are relative to each other. Well, but if you have 1,000 agents, and how do you tell somebody? It's like I didn't know what to do. It didn't make
Right,
any
right.
sense. So I
Yeah.
couldn't figure out how to
Useless.
get that to work. Yeah, but it's a good. I mean, that's a good idea, but I don't know. I couldn't figure out how to make it work. Anyway, I have another idea, which I've been thinking about this on and off for weeks, and so far I haven't dislodged it for myself. So I'm willing to propose it here. And this is the idea that attention is involved. All right. So just what is attention? And the idea here is that there's an attention area, and somehow it's used to determine relative pose. So let me just walk through a few ideas about attention. So the first one here, attention area. What do I think of it? It's like it's a body centric topographic area. Okay, that's available to everyone. So it's shared. So what do I mean by it's a topographic area in the sense that it's not like a reference frame. It's not like an area defined in a reference frame. It's literally like on the surface of the superior colliculus, there's a map of your body space. And if you activate a point on that surface of the superior colliculus, it's activating a point in your body space, like out here at this distance, at this degree of elevation, whatever. And so this is the topographic maps. Another example is like if your attention is drawn, if something moves off each periphery, we've talked about this, something moves suddenly there. This is a bottoms up, unanticipated movement. Your body immediately orients itself towards it. Your eyes move towards it, and you not only know the direction, but you also sort of know the distance. It's like you have a sense to how far away this thing is. So it's like a point or some area in space. And if you start looking at it, let's say there's some bushes there, and you see some things moving in the bushes. Well, those moving pieces sort of define a region that you're concerned about. You're trying to infer what's in those moving pieces. So there can be a bottoms up thing. It's in body centric space. It's not in any reference frame other than the body's body centric space. But it's not. I don't think it's represented by grid cells. It's really a topographic map of sorts. So this is my theory. This is not necessarily fact. Maybe this is known. I don't know, but this is how I'm thinking about it. And so you can have a bottoms up attention area, which I just described, like it can be defined by some parts of an image that are moving. That's what the part you're going to attend to, like different bits that are moving. Or if you have like a white canvas and you see some edges that are co-aligned, that could define your attention area. Um, so it can be static features, it can be dynamic features, and you can also have top-down attention areas that you could specify, like you're expecting to see something in a particular place because that's where your memory showed where it was. So that's what I mean by attention area. It's clear we have something like this that's going on, although the mechanisms I don't think are very clear at all, but maybe some people know that. And now the idea that might help out here is that the brain, I'm not saying where in the brain, I'm not saying if it's individual columns or something, I don't know where, but somebody knows where columns are relative to the attended area. So, it's like it's sort of like it's the same problem if I feel something on my skin, like I think it might be a bug biting me, my hand immediately comes over and slaps it. Well, it depends. My brain had to know where my hand was to make it come to that point, right? So somehow somebody knew where my hand was relative to my body space, and the little bug bite is relative to my body space. So we calculate, move your hand in the right direction to get there. That's all. Could be reflex reactions, but that knowledge is available. And the same thing happens. You can there's a lot of reflex reactions to attention that show that your brain knows where the attention area is, and then what reflex reaction should be done based on your body's position relative to that. So that idea is not a crazy idea. The brain knows where columns are relative to the attended area. And then somehow, that's the magic word, somehow, the pose of a column relative to the attention area is then used to inform the pose relative to the object. So let me just walk through this a little bit more. I can pick up any object, anything, even something I don't know what it is. And let's say I'm not looking at it, I'm just holding it in my hand. It doesn't really matter what it is. Independent of what the object is, I have a sense of the space it's occupying. So even if I can't recognize it, I still have a sense like, oh, it's in this space. And because if I have enough sensory fingers on it, or touch, even I've just somehow encapsulated it enough, then I have somehow some kind of concept like, oh, it's occupying a certain amount of space between my hands here, or between my fingers, or it's a lot of weird stuff we do. If I pick something up and it feels really heavy, then I know it extends further out. So if it's trying to bend my hand. So anyway, but somehow we want to turn this into like knowledge where my fingers are relative to this attended area, which is not a specific object. And then I want to say, well, if it is a specific object, how would I convert my knowledge where my fingers are to somehow this relative information? If it is a coffee mug, well, then knowing where my hands are relative to this attended area will tell me where my hands are relative to the coffee mug.
You would also need to know the orientation of the coffee mug in the where the handle, like how it is oriented upside down, right side up, where the handle is. Which I guess you
Right.
could do using the the long range connections in layer 6 potentially. If you
Maybe.
can
Well,
locate
well,
that.
what if? But you could get it wrong. I mean, you could make an hypothesis and be wrong about it. So I might pick up the coffee mug and I think it's right side up, but it's actually upside down.
Of course, yeah. But if you
So
don't
I would
know
guess
an
it.
orientation, like if you
But
don't
what's my
at least have a hypothesis about orientation, you still wouldn't be able to make a prediction about what to sense,
Hmm,
even if you know where you're in
interesting.
the intended
Well, you
area.
could start with it. You could start with like right. I think I see your point. Um, those are various sorts of mechanisms could be used. That you could just say, "Hey, I'm assuming it's right side up," you know,
Yeah.
or you could say, "Hey, I'm going to make an assumption based on its shape, its attentional space, that it's at an angle because I can feel these edges moving at an angle, something like that." I don't think you can't make a very precise prediction. You can take a guess. You can use
Yeah,
some
I guess
heuristics.
with oddly shaped objects, you could use the shape of the attentional area to infer the orientation, like where the handle of the mug is influences the shape of the attentional area, but it wouldn't always
But
be
again,
true.
at this point, I don't know it's a mug, right? This attentional area doesn't know it's a mug.
The
So,
attentional area doesn't, but I thought we did the grid cell anchoring with the object ID, so we know it's a mug. Now we just need to know where that would be
okay.
our.
If you're jumping ahead, I was
Oh,
moving
okay.
it right to the point where I don't know I have no idea what the object is yet. So something moved in my periphery. I have no hypothesis yet. Maybe I have no priors. Um, and I look over there and say, what is moving over there? So I don't know yet. I haven't voted yet.
Okay, I thought you were saying you have voted and now you move on the object and now you want to know where on the object you would be.
Well, I do want to do that, but that wasn't the problem I was just describing.
Okay,
Um,
then yeah, I
I
jumped
was
ahead
just,
a bit.
okay. So I think there's two things here. There's the object ID voting, which I like. So if we have an hypothesis, then everyone's sharing that hypothesis about what the object is. But there are situations where but that doesn't explain the pose. And I think there's situations where I need to know the pose, but I don't know the object. Or at least I have to know something about relative pose. This is why I emphasize the word somehow. It's like imagine this is a new object, or I don't know what the object is yet, and I'm holding it in my hands. I still have knowledge about its area, its volume, even if I have no, even if I don't have any hypothesis about what it is yet. So there's still knowledge about, independent of what the object is, there's some knowledge about where my senses are relative to each other. Um, and I think that's the important thing. We need to figure out what I'm trying to do is figure out relative pose of the sensors independent of particular objects. It's like, before I know what the object is, what are the relative pose of my sensors? Because we want to use that to help us infer the object. That's what I'm trying to get at here.
Oh, so this one is
Uh,
about the shared inference problem, not the moving on and off the object. So,
uh, well, it
uh,
could be both. I don't really know, since I don't know the answer yet. I don't want to say it wouldn't apply to that either. It depends on how it works. I don't know yet. Who knows? They might. The goal was hopefully they'd all sort of resolve each other simultaneously. Okay, we can just
One
break it down to two
one thing
things. I need to know I need to know what object I'm on if somebody knows, but I also need to know my relative position to other sensors, whether I know the object or I don't know the object.
Yeah, and I guess one thing is generally when we've been talking about attention, I think the way we've been conceptualizing it as kind of a distributed thing, and I think that feels still right or whatever. But when you talk
I don't know
about
what you mean by what do you mean by distributed? I don't know what that.
um, well, like you write here, is a shared body-centric topographic area. It's not like
Oh, shared, right? It's shared. I don't know if
but
it
it's
means
not
it's
like there's just
distributed.
one part of the brain that is doing this, or but I guess so yeah, and so that feels right. But I guess when you talk about having kind of a sense of the shape of attention, that was just making me wonder whether you could also have some degree of kind of metacognition where high like prefrontal cortex columns are actually modeling what our attention is doing, um, and sort of inferring, I don't know, attention shapes or um,
Maybe, but I do why I focus on the bottoms up stuff because it has to work with bottoms up input, and so I don't want to rely on precognition or prefrontal cortex, something like that. It seems to me there's a lot of these properties exist when it's all bottoms up. There's no model, it's model free at this point. And so I want to focus on
yeah.
those first because I think we have to solve the problem in a model free way.
Okay.
Um, the interesting about distributed, there are clearly these topographic maps that would suffice for attention. I mentioned the surface of the superior colliculus map like that, and that would be a primary candidate for like where to defining in its visual attention area because it could easily detect where movements are detecting and map them onto this literally a 2D sheet of cells on the superior colliculus. And I think there's similar maps elsewhere. I think there's maps like that in the the frontal eye fields. I think it has them like that too. Um, so there could be multiple attentional maps of some sort. I don't think of it as a distributed system in the sense like, I think each one of those is sort of independent in some sense. Like the superior colliculus probably runs on its own,
Right.
and if there's another one in the basal ganglia, it might run on its own, and in that sense, that's why I like to think of it as shared. Like there are things that can be used by multiple people, but I don't where the attention map is yet to be determined. But clearly there are some that are pretty obvious, and they're local. It's just literally a 2D sheet of cells that represents space around the body. Anyway, this is this issue here somehow. I feel like, let me try to explain it again. The solution, it feels like I've cornered myself into accepting, has to exist, that you need a method for determining relative pose or guessing relative pose or knowing something about relative pose that is independent of models, and therefore it's going to work through a sort of a body-centric area space, defined space, which is like an attention area. And at least there, um, I have the knowledge, at least I have the knowledge I need to start off saying, where am I relative to this object? Um, I have some knowledge. It's not perfect knowledge. I don't know the specific object, but I have this attentional volume or attentional space, and I can know where I am relative to that. And that's a lot of information. And how do you go from that to the specific pose of a column? I have no idea.
So is
I,
this now for like knowing the relative pose? Is this for voting or
well, it would
what
be for voting,
for?
right? It would be for voting. If I have a mechanism like this, um, uh, right, you're voting on some attended area, and every column could figure out where they are relative to that attended area.
Yeah, I guess I'm still a bit confused because like we have relative pose already if we assume that columns get their location in egocentric space, so they're in a common reference frame. And then they were still like even if you have relative poses, there were all these issues with voting because then you have to convert between like you have to apply the relative pose to the votes, which was the main
Right.
issue.
Well, so again, this is where I think we're slipping between neuroscience and Monty, maybe. Right. So you have these things in Monty, and I don't think about that. Um,
I mean,
so you
well,
know,
I mean, if voting is just an associative connection, it seems like you couldn't apply a relative pose in between. You can't rotate something in an associative connection or displace
well,
it.
I guess I'm getting lost. I think all I'm trying to say is, uh, right, maybe you already have this assumption in the money that a column has to have some information about its position relative to a common space with body space,
Yeah.
and and now if I have an attended area where I think an object is going to be inferred, then and I know the area that area is defined by literally a set of activations in the neuroscience. It'd be a set of activations on the subsurface of the supracolliculus in some sense, right? Um, and if I know where it is relative to that, I have information I could use. It tells me something about where I am relative to the object, not in the object reference frame, but in this attentional area. And now maybe you already have this information in Monty because you maybe already have this idea of a body centric position.
Yeah.
And what is the problem then? I mean, is it the same problem? Like I don't know how this works. Like somehow is that the same problem?
Well, it's more like we assume that we have relative poses because we get locations in an egocentric space. Disregarding attentional area, it's just we have a map of where our sensors are relative to the body. Each sensor knows how it's moving relative to the body. And then, given that we can do voting on poses, but it requires transforming, like applying the relative poses between
Well,
votes.
like
And then that was the main
between
issue that,
okay, so between columns, you mean, right?
yeah,
Right, yeah. So I think that doesn't work. Maybe it's what you're telling me. I
right.
think the idea that I think the idea that let's say that we're all in this room, there's 10 or 9 of us on the call here. We're all, I'm lost. I have no idea, and you guys all know where you are. And then, okay, fine. Who do I ask? Who am I going to compare myself to? OJ, Niels, Rami? I don't know. And then do I have to do like this transform between? Okay, Monty, where are you in body space? I'm in body space. What's your pose to the object? Okay, then I can calculate my pose to the object. I mean, that could work. I don't see why that wouldn't work, but it doesn't seem biologically plausible.
Exactly, that's
Um,
what I'm saying. That like that's what we currently do in Monty, but it's not biologically plausible. But the issue isn't that we don't have access to relative pose. The issue is that applying the relative pose is such a complex transformation that we can't imagine it happening in the
right.
voting
So I don't.
connection.
So all I've done is move this into a. I've moved it down kick the can down down the road a bit here, saying, okay, I'm going to assume this is the attentional area. That's not quite the same as body pose, right?
Yeah,
There's an extra layer of information here, which is the area occupied by the object we're inferring, and that's and so I'm going to use that, not what the other 8 of you know where you are. because I don't know what to do with Hojo's knowledge and your knowledge, and it's too hard, right? It's just too hard to calculate that. So I'm not going to pay attention to what you guys are doing. All I'm going to pay attention to now is okay, there's this area in space called the attention area, and I know where I'm relative to that. So what information can I extract from that helps me vote,
Yes, it's kind
or
of
helps me do
changing
anything?
from many to many to many to one.
Right, right, right.
And
But in a way
packing.
that's weird because it's not, it's one, but is it one? It's an attention area, which is a bunch
Yeah.
of cells that are active. So I haven't really worked on this problem further. It took me a long time to think of this idea that, okay, we have this other layer, this attentional area, that's the thing that's important. It's not where the other columns are. I'm not going to pay any attention to them. I have to take all I can do is pay attention to this attention area. Maybe that's the big change. If you already know where you are relative to the body, we don't want to look at other people, other columns. We want to
Uh,
figure out how to solve this problem by looking at the attention area.
Yeah, so when you say used to determine relative pose, it means relative pose relative to the attentional area, not relative to other columns in the
Right, right,
attentional
right,
area. Okay,
right,
yeah.
right. Well, and the attention area is sort of like a pseudo object, right? It's sort of object related, but it's not it's not it's like, it's like, okay, if the attended area was a rectangle, I would say, oh, I know where I am relative to that. I don't know yet. I haven't gone further. I guess the whole idea is just say that a column is going to look at this attended area and where it is relative to the attended area and somehow influence its pose.
Yeah.
Um, and
Yeah, that
not
definitely
really
feels a
pay
lot more
attention,
tractable if we can get it to do everything we want.
right? So I think it's a promising direction. Um, and I think, I just have to we have to walk through I haven't even attempted yet. I've been attempting trying to solve the somehow here because I just want to get this problem crystallized in my head first. So it's like it's sitting on the side of the table over here going, oh God, we got to figure out how could this actually work, but not yet, not yet. Don't try it yet. I don't want to get confused. So anyway, that's why I said, I'm not really prepared today, but I said this is the direction I think is promising. Using the attended area. Um, there's other places we can look. There's like what and where reasons, still a mystery to me, as to what their relative position, the roles are and how they work in this regard. There's a possibility we talked about, could different regions or different columns be doing different aspects of the problem. This is very general. We talked about, maybe it was in Milan, I don't remember, but we talked about potentially playing back sequences to learn, to train everybody. Um, that had problems too. So I just want to recognize there's other things that we've talked about that might be important or not. But at the moment, I just want to focus on this idea. Um, and
I have
see.
a
It just seems
sort of thought
promising.
on the attentional area thing,
Yeah.
which I feels very clean and very nice when you think about the superior colliculus and how that maps into V1. And, it just seems easy to create a mask that way. So here's this section of columns that are
Yeah.
sort of
Right.
related. But I wonder about um, whether or not that superior colliculus sort of mask or whatever you want to call it can sort of cleanly map into the thalamus as well, where influence there and how it decides like it's going to um,
Well, it could, right?
uh,
I mean,
that way the things that all the columns that are learning within that region, if the thalamus can be the one that sort of provides, okay, here's the sort of pose. And
it's a very
yeah.
good thought, Scott. Look, because first of all, the thalamus is also topographically mapped, right? So,
Mhm.
anything that projects to it's also topographically mapped. The thalamus has been implicated in attention many, many different ways. The TRN, which is the surrounding reticular nucleus, has also been implicated in attention. I mean, implicated like fuzzy stuff. It's fuzzy sauce. It's not like detailed mechanism. But there's a lot of people suggested that thalamus is involved in this, so it could be the thalamus is playing a major role here. I think that's all you're suggesting. Is that right? Or
Yeah, and that's a
okay.
mechanism by which the columns that are doing the learning can have the same sort of pose, essentially. They can kind of share pose information
Uh,
because it's being sort of determined more at the thalamic level.
well, so you're going back to the idea that um, that
I think
well, all
Jose.
right. I think that all right. I mean, before going, Jose, the general idea that the thalamus could be playing a role in making this somehow question work is a good idea. How about
You mean
that?
Scott?
Oh, Scott, sorry. But you were. I thought you were going to say something, Jose.
No,
No.
I was saying
Oh,
Jose was kind
oh,
of talking about something similar before, right? That was what you were
oh!
saying about
I thought you were saying
L6B.
Jose wanted to
Sorry.
say something. Oh, wait.
It's okay. Scott and I are generally one person.
Let's go, Jay.
So, all right. So that was your idea back up. But the only thing that confused me, what you said earlier, Jose, is like, uh, well, again, we'll say that a column projects both L6A and L6B project back to the thalamus. And so the location and the orientation are the pose information at the thalamus. We don't know what it's doing with the location information. We have one thing we know is what it's doing with the orientation information. It's helping with child objects, we think. But right, so all the information, a lot of information we need is going projecting to the thalamus, and some places an attention area, and somehow the system figures out what to do. I don't know. um, if you want, I could just finish up my little page of notes here by talking about the second set of problems that I'm working on. And that's at the
Yeah,
bottom of
sounds
this
no,
page.
that sounds good.
So these are problems related to classes, forking models, when you create a new model, when you don't create a new model. Um, so when do we create new models and how is prior learning? And so we have this, we've been two questions like when do you create new models? And also if you create a new model, so often we want to incorporate existing knowledge into that new model. It's like, it's like if I see a mug with a mug and I see a mug with a logo, do I have two separate models for that? And if so, how does the information get transferred between them? And you can't do that. So this is another area that I think is important. Vivian has brought this up to me a couple of times, saying, "Jeff, we really need to understand how but when we create new models and when we don't create new models." I know it's a well-known problem, some you've been working on, and I just want to point out that the way I view this problem I've sort of dividing into two categories. And I'm not sure if this is correct or not, but this is how I've been thinking about it. So these are one category is you have two objects that have the same morphology, but they differ by children. So this would be like a mug with a logo, or a mug with a logo B, or a mug with a logo C, or a mug without a logo, or whatever, things like that. Or it could have a sticker on the mug and a logo. It's just these are all mugs, and they have different children associated with them. You might even think like, oh, perhaps the handle is a child, so it could be mugs with the with or without the handle. But the mug shape itself is going to be pretty similar. Then there's another class of things when you have two objects that have similar but different morphology. So you have a mug with straight sides, and then a mug which is conical in shape. Well, they're really not the same morphology anymore. They're not differing by children, they're different by morphology, and there's this like continuum between purely vertical and really shallow and round. I don't know. So I think those might be two separate problems that there might be handled differently, but I'm not certain about that. So this is just another. I don't have any more to say about this today. I just wrote out a post last week about the idea about that we might be learning all the time, and that might be part of the solution to this. That we're always learning new models, continually replacing our models, and we never create a new model. We never decide to create a new model because every event observation is essentially rebuilding models I already have, and I don't know how that works yet. So, but anyway, those are two. This is two big areas that I know this is not everything we have to do. But these are two big problems areas that I'm thinking about.
Nice. Yeah, were there any other questions or comments people had? Cool. So yeah,
I
we've
just
got
have
about
one quick
oh yeah,
question
go
or
ahead.
thought. It has to do with sort of model sharing between columns. And if you know, if them all being in the same pose, I guess is maybe more of a math question or than it is conceptual. I'm not sure, but if all the columns are in the same pose, is model sharing easy, or is it much harder when they're in the different pose? Like if they're all assuming some sort of different orientation,
What do you
or
what do you mean
Well,
by
if they're
model
all assuming
sharing?
the same orientation.
As
Sorry.
in like when you say model sharing, like what
Yeah.
information, I guess, do you mean is being passed? Like,
Yeah. So that if a bunch of neighboring columns in the fovea, for example, you know, they can fill out each other's models
you're talking about
if the
shared
thing being
training.
learned has the same sort of basic pose. Like if if they're all learning it in some aligned, if there's alignment between their
Well,
anchorings.
well, but I mean, I'm confused by that question, Scott, because um, I'm trying to imagine. We're talking like V1 or something like that, like a
Yeah.
primary visual cortex. Okay,
Yeah.
so if they're looking at different parts of the retina, and if
Mhm.
they're all getting input, they might have the same orientation, and they might have a different orientation. Oh, you're saying, oh, because of the retina, they all have the same
I think you're
orientation
saying
to
the
the
orientation of the
object.
object, right?
I
Oh, I
guess,
say
well, actually,
orientation of
now
the
that
object.
I'm trying to think about the anchoring and the sort of particular way that the grid cells or grid-like cells in there were sort of aligned, if their sort of anchoring is aligned because they're sort of, for some reason, they're being induced to have the similar kind of alignment of or anchoring of their grid cells. Does that improve, or I would think intuitively that would help the ability for them to sort of share their information?
Yeah, and and even if they're not like directly sharing information, like I don't know, let's say they're all getting movement information in parallel. I think it
Hmm.
does make it easier if yeah, they have kind of a common sense of orientation. I mean, firstly, it makes it more likely that we could learn to vote about orientation
Hmm.
if they're kind of consistent. And then yeah, and it doesn't seem crazy that they would be consistent if yeah, they're kind of initialized together and learn together. Like that's kind of what we assume now. Um,
Yeah, and well, sort of somehow the sort of model-free aspects of our image, maybe there's a lot of up-down oriented kind of stuff in this sort of general attentional area. It sort of biases the way that they're anchored, each column, and that could be coming from the sort of proto-object model-free area if it also includes some orientation of the proto-object. Then it allows the models or the columns to share more easily. So I guess the idea is that it's not just a proposed area in space or pseudo area, but if there's any sort of orientation content in there, so it's a proposed an intentional area combined with some orientation information that allows
Well,
not
it's interesting
just
because
a mask, but an oriented mask in a way that
right. Well,
influences
there was
the
a question:
alignment.
Does the mask have an orientation, or do we know the orientation of the other columns? I think you start off by talking about the orientation of the other columns. Um, I mean, again, think about your fingers. They can have they're represented next to each other in the cortical sheet, but they have different positions and orientations.
Hmm.
So
I guess I wasn't really
yeah,
thinking about the orientation of the sensor so much as I was thinking about the anchoring of the grid cells onto
well,
an object in
hmm,
visual space.
interesting. Uh, Whew. You just
yeah,
brought up a
and
crazy idea.
I'm sorry, go ahead.
No, it's a crazy idea. I shouldn't bring it up. Rami would like this idea. I was thinking like, what if um, what if the object ID wasn't just object D? What if object ID and orientation? It's still an SDR, and you're not. I'm not saying that those two items are represented independently in the SDR. I'm just saying that what if the object ID was unique to the object? What if the SDR voting SDR was unique to the object and to the orientation? And because you're talking about how do we I don't know. That was a crazy thought. It's related to what you're saying, Scott, I think. I think it was, wasn't
Yeah.
it?
Yeah.
That somehow
I
the
mean,
good columns would vote would tell each other something about the orientation of the object.
Yeah,
yes.
so yeah, I think orientation, both communicating up the hierarchy and voting on is something we've talked about before. Um, I mean,
But
maybe
this would
I'm
be
wrong, but I think what you're suggesting, Scott, is like, could the proto object, the kind of subcortical, yeah, let's say it's in superior colliculus for vision, could that be capturing the orientation of the proto object, and that could that maybe be useful for almost initializing the hypothesis space about the orientation
Yes.
of the object in the columns?
right,
That
right.
is kind of like
That's
part of this, but also object generalization. If things have, when I learned this thing, it tended to be this cylindrical type object. I, and my columns were biased in terms of its grid cell anchoring by the visual features being sort of upright. I see another similar kind of object. The anchoring there is initialized similarly just because it's got similar kind of vertical features. And so now those objects maybe are more likely to be considered part of the same kind of class or category because they're sort
true.
of common alignment.
When I think about the attention area, I always think it's totally model free. So I think just I might be wrong, but that's how I think about it. And therefore, anytime I feel like proto object or something like that doesn't make sense. But I think the idea that when a column says, okay, there's an attentional area, and where I am, there might be a shared idea, not just where the object is, but a shared idea what the orientation of the object is. At least everyone can take a guess. Um, it's like, remember the spotted dog picture where you have all the spots and you can't see the Dalmatian dog? We've seen
Hmm.
that many times. It's a very telling image. Um, and it's so hard. And why is it so hard? It's because, well, there's no clues in it as to the area where the dog or anything is. Even if I tell you there's a dog in a picture, you have no idea. You can't figure out any kind of clues. There's nothing moving and there's no edges anywhere. Um, and but even if I said, okay, there's something in this rectangular area here, your assumption is going to be vertical. I mean, it's like you're not going to expect to see an upside down dog there,
Hmm.
and if there was an upside down dog there, I bet you wouldn't see it. You better not see the right side up dog. So my point is, this is suggesting what you're saying, Scott. I think there is a sort of a there's an I think what you're saying is there's an assumption about the orientation that could be shared among all the columns. So if everyone says, "Well, I know where I am relative to this thing," and we're all going to guess that this thing has some relative, it's just some orientation in the world, and we're going to at least start with that assumption. Um, and so we all know our relative position to that. We would know our pose, our complete pose relative to that guess.
Hmm.
Um,
I think
is that somewhat?
we, oh, sorry.
Yeah, go ahead. I'm out of ideas.
I think we discussed a similar idea in London on the first day, which was that we detect the general shape of an object in some kind of model-free way, like, I don't know, superior calculus or wherever, and then use that shape to initialize a generic reference frame. And location in a generic reference frame would give the column a lot of information, like would resolve the need to vote on locations. It's a bit similar to the idea of using the attentional region. Um,
Right, right. Now, thanks for bringing this up. This is really good. But this is the idea that we have a reference frame, and
yeah, but then I think, yeah, and we said there would be like basically this idea of the generic reference frame for the generic shape, and then kind of mini column activations for the specific object ID's reference frame, the specific object's reference frame. But the reason we kind of discarded that idea again was because it seemed like the model-free way was like not powerful enough. Like it wouldn't be rotation invariant, it wouldn't be
Right.
viewpoint invariant. Like the same object from different viewpoints can occupy very different areas on the retina, for example.
I
Um,
think, yeah, maybe this will uncover this again, trying to think through it, but I feel like we were expecting something different of this mechanism. Because I agree, it was very simple. Because yeah, we even said like, oh, maybe this could be happening down in the thalamus, that there could be or superior colliculus that could be defining this region, and um, but we were kind of almost expecting object recognition to take place um in this model-free way, which, as you say, is going to be really limited. Whereas if it's literally just about defining relative locations, maybe it could still work.
Hmm.
Yeah.
It's funny. I can't remember this at all. It's so bad. But it's not, I'm just so I'm reading the notes saying, oh, what did we say? It's like, so would it be correct to say that this is similar idea here, but this was assuming there was like a grid cell type reference frame? Is that what we were thinking back
Yeah,
then?
it's a similar idea for a similar problem. It was also about how can we vote on locations. And so the idea would be that we initialize a generic reference frame for that kind of shape, like the oval of the face. And then
Hmm.
we use incoming features to figure out the locations on specific models, so specific reference frame, which would be then
Hmm.
kind of mini column activations. And so there would be two spatial representations. One would be like general for anything that's oval shaped, and
Hmm.
then specific, like the specific
Yeah.
face. And the location in the generic reference frame, which can be determined in a model-free way, would give the column a lot of information already, like where it should be on the
Well,
face.
is it really a model freeway? Or it's just a simpler
Well,
model,
yeah, I guess it is some type of model. It would be like a model
right?
of that shape, and yeah, the area is
Right.
on the
So
face.
that is, I mean, just intuitively, I don't like this as much.
Yeah.
I mean, we could go into why, I don't know, but there's all kinds of issues. Oh, well, how do we learn those generic shapes and where are they represented and blah 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 blah. And the fact that the other thing is that it's like I know we have to have this attention mechanism. I know it exists. We're just certain that there's this attention mechanism, and it's clearly important. And I would say the attention mechanism has to work independently of models. I know that it often does. That's a fact. Um, so makes me want to pursue that area, that direction further, as opposed to this. This assumes that there are some sort of proto models that had to be learned and have to exist someplace, and you know that's more. Even though might have been, I don't know whose ideas those are. Maybe they were mine, but it's not as good as the one I presented today. I think.
Yeah, I agree that it had problems, so we discarded it again. It just came back to me because it sounded maybe a bit similar to what you
Well, it
mentioned,
is. I guess
Yeah,
we're
I
sort
was
of
also
meant in some
thinking
generic
about
sense.
this.
reference
Yeah.
frames.
Maybe we're beating around the same idea over and over again. There's got to be a solution to these problems, and so you kind of try different things, and it is related. But I think this is but the attention area is a variation on that idea. So it's like, oh well, maybe that didn't work, but this attention area might work.